Darkness, humidity, more darkness. You have been wandering in these caves for days now, searching for the legendary hammer of Lambda, and you found nothing so far. You enter a large room of typical Dwarven architecture. In the distance, beyond rows and rows of pillars, a bonfire flickers, illuminating a tall archway and the silhouette of a creature that appears to be standing guard. What do you do? What do you do? You could do many things. You could take a bow and an arrow and shoot at the creature. You could hide and try to come closer, talk to it. You could just go away. If you're a wizard, you could cast a fireball. You could do many, many, many things. So what do you do is up to you. This little snippet I played for you has the two elements which I think are at the core of role-playing games or RPGs. So to play a role-playing game, you really need two parts. The first part, it's all about a story. It's about storytelling, it's about living together an epic story with battles, with treasures, with monsters, with heroes, something like Lord of the Rings, like Bilbo the Hobbit, Conan the Barbarian. So this is the big part of it is about having a story. The part which makes it different from watching a movie or reading a book is that when you watch a movie, sometimes you see the hero do something and you think to yourself, is like, this is silly, I would like to do something else. How would things play out if they had done something different? So this is where role-playing games come in, is like instead of watching the story written for you and unfold in a particular way, you get to decide what is it that is going to happen. So these two parts are like the core elements of a role-playing game. At that point, you might be wondering, this is great, but what does this have to do with software? Like this is NDC, and the D in NDC is not dungeons, it's not dragons, it's developers. Another question you might ask is like, who is this person speaking? So first I should say, hi, my name is Mathias Brandewinder. You can find me on Twitter as Brandewinder, as this little guy here. Usually, I speak about things like functional programming and machine learning, but something really nice happened to me last year. I got to realize a childhood dream. Like when I was a teenager, I bought all the books for Dungeons & Dragons. I knew all the rules, everything, and I never got to play a game. And so this ended up being like one of these childhood dreams where you put it on a shelf or you think, too bad, it will never happen. And then a friend of mine told me last year, we should play together. Let's play Dungeons & Dragons. And so I have been playing a campaign as the Dungeon Master for over a year. And this has been like really, really awesome. So that was good already. Now the connection with software is the following. It's like as I was doing this, if you have played Dungeons & Dragons before, you probably know that the DM kind of needs to know all the rules, and there are a lot of rules. So I had to know the rules. As a software engineer, I thought, fine, like the best way to know if I know the rules is I should be able to write them down in code. The moment I have the rules coded in software, then I know them and it's clear. So I started on this project to just try to encode the Dungeons & Dragons rules in my favorite language, F#. So this is what I did, and this is what I'm going to be talking about today. And presenting you this project, and what I noticed also when I was doing this was that even though D&D is a pretty specific domain, like a lot of the things I was hitting by doing that were actually quite similar to things I was doing in business applications. So what I want is like to share with you a couple of ideas, a couple of things I found, and maybe you will get something useful for your own code. So our campaign today will be progressing in 4 arches. Like the first one is like I will probably talk a bit about what D&D is. Unsurprisingly, when I started this project, is like I realized that a lot of my software engineering friends did know D&D and played it. I just didn't know that. So I suspect that probably a good part of you know the game. For those of you who don't, I'm going to introduce a bit what the game is about and how it works. Then I'm going to attack a first problem, which is like D&D is full of monsters. So how would you go about modeling a monster with F#? Then we're going to move to a slightly different problem. D&D is known for being played with dice, a lot of dice, like they're everywhere. And so we're going to look at how would you go about modeling dice rolls in that language. And finally, I'm going to show you like a tool I have been building, which is a sort of a D&D combat simulator in Fable Elmish. That's what we're going to finish with. So let's start with D&D, the rules, and how the game works. So a game in general is about agency. It's about giving an actor the capacity to do things in an environment. To make a game interesting, you probably need a couple of things. Like the first thing is like when you take a decision, that decision should have some consequences. If what you do doesn't impact anything, this is not a fun game, you're just watching something. So you need to have decisions, you need to have consequences, and for the game to be interesting, you should also have consequences which are not completely random. If whatever you do, the result is either the same or is not connected to what you do, it's not very fun. It's interesting when you make a decision and you kind of wait in like, this is maybe what I should be doing, and then you're happy because when it succeeds, you know you are right and you are smart. So this is how you make an enjoyable game. And so for this, you need to have some form of rules so that you know what to expect. So D&D, or Dungeons and Dragons, is only one of many role-playing games. It's the granddaddy of all of them. Like I was surprised to see that the first publication was as old as 1974. So that's a pretty old game now. What this means is like it means like it has gone also through many, many iterations. So I'm going to be talking specifically about D&D 5th edition. In traditional software fashion, like 5th edition doesn't mean it's the 5th iteration. I believe it's the 11th. Like software is not the only place where like version numbers have a problem. It's a role-playing game, and the universe in general is loosely inspired by Tolkien, like Lord of the Rings, Bilbo, all of that. Somebody actually pointed out to me on the internet, because that's what people do, that I was wrong. And it's actually not based on Tolkien. It's like technically it's based on Conan the Barbarian. So I didn't know that, but like now I know. So the rules, the core rules are one book called the Player's Handbook, or PHB. The PHB clocks in at 316 pages. If you want to play the game like for free or without getting the full book, you can actually get the basic rules, which are like 180 pages for free online. So the minimum set is already like close to at least 200 pages of rules to model. So that's not a small thing. Really, if you're serious and you want to do a game, you will probably need 3 books. The first one is the PHB, 300 plus pages. The second one is a Dungeon Master Guide, also over 300 pages. The third one is like the Monster Manual, also over 300 pages. So overall, is like we're talking about something like a spec over 1,000 pages. So this is also probably what I thought would be a couple of weeks or weekend project. Like it ended up being like over 6 months now. I was a bit naive. Like I thought it would be quick, and like guess what? I'm still nowhere close to be done. If you play the game, there are a couple of things which happen. Like one is like the game has like 2 very distinct roles. Most of the players are actually players, so the players are the ones which are living the adventure. They are like dwarves, they are like elves, whatever, and they make decisions and move into the adventure and decide what happened. To make that work is like you need another person to actually run the world around them to tell them like, you did this, this is what is going to happen. So that role is what people call the dungeon master or the game master, and essentially the game master is the one which is the universe, and like you tell them what you want to do and they tell them what happens. So 2 roles. The other thing is like the game goes through 2 slightly different phases. One part is really about storytelling, like talking to characters, like deciding things, making plans. So that part is pretty flexible. It's pretty focused on interacting with each other. That's loose. The rules play out here, but like, they're not that important. And then, of course, like being a Tolkien-inspired universe, you have also a lot of combat. And so whenever you encounter combat, like the rules become very rigid. At that point, is like it's essentially a war game where you have turns, like you have 6-second turns. You can do very specific things, and so this is pretty set. As a software person, so I could try to model the part about the role play. Trying to automate something about creating a story and dialogue it's a very interesting project, but like this is huge, and so this is not what I tackled. In traditional software engineering fashion, what I did was like, let's take the piece which is the most boring or the least interesting and try to automate that. So my focus was mostly on modeling combat in D&D. This is what I'm going to talk about. So let's talk about domain modeling and taking that domain and modeling it with F#. So what I said earlier was you kind of need some information as a player to decide what you should be doing and what the consequences of your action might be. So for instance, like you could be meeting like one of these 2 creatures in a dark corridor, and these 2 things are pretty different. Like on the left, you have a creature which is a goblin. A goblin is like 4 feet high. It's not very strong. It's quick. It's mean. The one on the right is an ogre. So an ogre is something like 7 feet high, like a couple of 100 pounds. And so if you saw these two creatures, is like you would probably do different things. The question is like, how do I model this with the rules so that you can actually simulate that and take decisions? So the way you would do this in D&D is by using what's called a stat block or a sheet. And this is a summary in one page which tells you like what you need to do, what you need to know about that particular creature. The main block we're going to look at is like this one here first. So this one is describing like 6 attributes for the creature. So if I look at the player handbook, page 173, it defines like abilities. So abilities, 6 abilities provide a quick description of every creature's physical and mental characteristics: strength, dexterity, constitution, intelligence, wisdom, and charisma. Fine. How would I model this with F#? I would use something which is called a Discrimination Union. What I said is like I have 6 different characteristics. This is all I have, and an ability needs to be one of these things. I would model it this way. I would say I have a type which is an ability, and an ability can be one of these 6 things. It can be either strength, or dex, or constitution, or int, or wisdom, or charisma, so on and so forth. Not too difficult, modeling done. Each ability, player handbook, page 173, each of a creature's ability has a score, a number that defines the magnitude of that ability. So now I'm making a slightly different statement. I'm saying if you give me a creature, that creature should have a score for each of the 6 abilities. To do that, what I would be using is what's called a record. So a record is like similar to a class loosely. And here my record would be maybe called scores. And I will have a score for strength, that would be intelligence, a score for dexterity, that would be an int, constitution, that would be an int, and so on and so forth. So now I can package my 6 things into one record. How would I use this? For instance, how would I go about saying, like, give me the dexterity score for that particular creature? To do that, I would use pattern matching. So pattern matching is if I wanted the score, I would need 2 things to give you that information. I would need to know the scores for that creature, and I would need to know what ability are you talking about? Like, what do you want to know? So the first thing I would say is, like, I would match on the ability, like, did you ask about strength? If you ask about strength, I'm going to give you the strength from the score. If you ask about dexterity, I'm going to give you the dexterity from the score, and so on and so forth. So I'm matching. I have 6 possible cases only for each ability. For each of them, I will choose what I want to do next. Modifiers. Each ability also has a modifier. To determine the modifier, subtract 10 from the ability score and divide the total by 2, rounded down. Good. So how would I do that? This is easy. Like all I need to write a function. So I would write a modifier function, and the modifier function is going to take a score, which was an int, subtract 10, divided by 2, happens to be rounded down. Finished, I can move on with my life. So this is also easy. And so at that point, I'm able to model like the, say, a goblin or an ogre. Like to create a goblin, what I would do simply is I would say create a record. Strength equals 8, dexterity equals 14, all these things. And now I could do something like give me the modifier for the dexterity of the goblin. So I would say like give me the score for dex for the goblin, take that and apply the modifier function, which will give me whatever the modifier is. Not too complicated. One thing which is not nice here is that you start to have parentheses and parentheses and parentheses. So there is an idiom which is very common in F#, which is like the pipe forward. So instead of like wrapping things in parentheses, you could say, what I want is I want the goblin. From the goblin, I want to get the score for the dexterity. Once you get that, I want you to push that into the modifier function. So another way to write the same thing, but which is pretty clean. So we have a goblin, which is nice. We have an ogre. We have all these things. All I did here was really introducing something which is not that complicated, but which has a fancy name. So the fancy name for it is called algebraic data types. So if you went to Wikipedia and looked for algebraic data type, you would find like this not particularly enlightening definition. An ADT is a kind of composite type formed by combining other types. So that's probably not very helpful. I think a more helpful definition or a more helpful way to look at algebraic data types is to think about it this way. You have types, and the types can really be one of 2 things. They can be a sum type. So a sum type is like a discriminated union, and these types are about OR statements. For instance, I said like an ability can be strength or intelligence or wisdom or charisma. Whenever you hear an or statement, you're probably talking about a subtype or a discriminated union. The other case is you have types which are product types, like that would be records. In general, that would also be tuples. And these types are about and statements. Like what I said is like a goblin has like 6 abilities. It has intelligence and wisdom and charisma and this and that. So or is a discriminated union and is a record. That's algebraic data types. And so at that point, you're ready to level up. You gained a new skill. You know about algebraic data types. So let's move up into the adventure and let's revisit a bit the stats block and see if we can move a bit with modeling to a different part. The part I'm going to look at next is the part about making attacks with weapons. So that's the piece which is described at the bottom here, which I blew up here. So if you look at the goblin stack block, you will see that the goblin can attack you in 2 different ways. It can attack you with a scimitar, that's a curved blade. This is a melee weapon attack, +4 to hit, that gets a bonus on the attack, reach 5 feet, 1 target, 1d6 plus 2 damage, slashing. You can also attack with a short bow, so it's a ranged weapon attack, +4 to hit, reach either 80 or 320 feet, 1 target, 1d6 damage, and this one is piercing and not slashing. So how would I go about modeling this with our algebraic data types? The first thing I would do is like if I look at these 2 things, there is an obvious parallelism between the 2 attacks. Like a lot of things are similar. I see that I have a weapon name like scimitar or short bow. I have something which looks similar, like either a melee attack or a range attack. I have a bonus to hit. So these things look like quite parallel, and it looks like it doesn't, regardless of the attack I'm going to be using, they have like some of the same characteristics. So this would be probably an and statement, like it's probably a good candidate for a record. Like what this is saying is like an attack is going to have a name, it's going to have like a hit bonus and all these things. So to model this, what I'm probably looking for is a record. If I dive in inside the description, I also see that there are places where these are probably not records, but I see a bunch of or statements. For instance, like the scimitar is a melee attack, the short bow is a ranged attack. So what it's telling me is like an attack can be either melee or ranged. That's probably a discriminated union. I see that I have a reach of 5 for the scimitar, and I have a reach with 2 different things on the short bow. So it looks like I have a range of 1 type or another type. Probably also an or statement and probably also a discriminated union. And I see slashing or piercing. This is also or, so I probably have a discriminated union here. So let's dive into the first one I raised, which was like melee and ranged. So a player handbook, page 146, melee and ranged. Every weapon is classified as either a melee or ranged. So either or, also discriminated union. A melee weapon is used to attack a target within 5 feet of you. A ranged weapon is used to attack a target at a distance. Fine. So let's dive into range. A weapon that can be used to make a ranged attack has a range in parentheses. So that's the case of the short bow. The range lists 2 numbers. The first one is the weapon normal range. The second one is a long range. So if you shoot with a bow, if it's close, it's easy. If it's far, it's harder, is what it's saying. So so how do I do that? So what I can see here is like I have a reach. And sometimes, so the overall sketch of what I have so far is something which is probably like a record. It's going to be a record which is called an attack, has a description, probably a string. I have something which is probably melee or ranged, I don't quite know yet, but like a type of attack. Hit bonus, this is not difficult. And I need to deal with the reach. And the reach can either be 5 feet if it's a melee attack, or like 80, 320 if it's a ranged attack. How would I model that? So I probably want a discriminated union. Here, I'm going to show like something I haven't shown so far on discriminated unions. Is like discriminated unions describe different cases, but what you can do also is like for each of the case, you can attach different types of data. So what I can say here is a really, an attack is going to have a reach. If it's a melee attack, the reach is going to be 1 number, like 5 feet. If it's not a melee attack, it's a ranged attack, and I will give you 2 numbers, like the short range or the long range. And so now I can say like my attack has a reach, which is of type reach, which can take these 2 shapes. Nice, easy. We can move on. And if I wanted to work with this, I would use pattern matching again. So I would say if I wanted to know how far you can attack with something, I would take my attack record. From the attack record, I would take the reach. If the reach is melee, I know I have 1 number in. I will unpack it and give you that. So that would be 5 feet, for instance. And if it's ranged, I know I have the short and the long range. I would unpack it and give you back the long range. So I can put data in. I can get data back out. Easy. If I wanted to, like, I could be a bit cleaner because like 2 ints as a tuple is not very clean. So I could actually create a record inside my discriminated union and say when it's ranged, I have a short range and a long range. Same idea, just like slightly nicer. So now I have like a record with a discriminated union with a record inside. I'm just like nesting dolls in Russian fashion. I could also use a module to clean up the code, so that's not particularly important. And so at that point, is like we have a pretty solid model. Like with this, we could model pretty completely the attack. Like it was not complicated. Like there is just one issue at that point. And the issue we have is like we can represent both the scimitar and the short bow attack, so that's good. We can represent anything we want. The problem is that we can also represent things we don't want. This is why I'm calling this a chimera. So a chimera is a monster which is composed of different parts which should probably not exist, like something like a lion and a dragon and a goat. And here the problem I have is like I could write an attack which is of type melee, but could have like a range which could be short and long. This is not right. Like I should not have like something which is both. It should either be a melee attack with 5 feet or like a ranged attack with the 2 ranges. And now I can completely create this hybrid type which is like not valid. So one way to handle it would be let's put like try-catch blocks everywhere, make sure that it works. Another way to do this is like if you have a problem, is like either fix the problem or like you just remove the problem so that it doesn't even happen. So this is a mantra you will hear from some functional people. Is like one of the goals would be if you can use your type and try to make impossible states unrepresentable. So what I want is I want to remove that problem altogether. Symptom would be if you see something like pattern matches with exceptions, you probably have that type of issue and you probably want to revisit that. And here the solution is not very difficult. It would go along these lines. What I really said was I have melee or ranged attacks and I have melee or ranged like a reach. In the end, is like if you tell me like the reach is a ranged reach, I know very well that it's a ranged attack. I don't need to have another field. Same thing for the melee. If I have a melee range, it's like, why do I need to know what type it is? I know it's a melee attack. So all it would take would really be like remove the other thing and say, I just have a reach. The reach will tell me both if it's ranged or melee and how long it goes. Fine. Now is like I'm in a happy place because I know I cannot create like horrible types which are a chimera anymore. Problem removed. We are in a happy place. Cool. So this was like essentially like the first weeks or weekends was all about like modeling things, doing this. Along the way, like everything was going fine, but I also hit a couple of pitfalls which I have seen in other places. So I figured I would talk about these for a little. So what traps might you encounter when you get like a document and trying to model it? The first one is like, so Roll20 for deception is like, one, the domain is very well documented, like the rules are complete, this is what you use to play, so this should be easy. But if you start to look at the documentation is really full of either lies or at least half-truth. So my first, the pattern I followed was look at these 2 attacks and take them as a template for every attack which exists. Fine. Now, if you go to the monster manual, you will see a lot of monsters. And for instance, you could find something called a Wyvern. So what a Wyvern is like a slightly less powerful version of a dragon. And so you look at the Wyvern and you look at the description, and you will find that the Wyvern can make the following attack. And so first statement is like that looks like much more complicated than what we saw for the goblin. So what is going on? The Wyvern can do a stinger attack, like it can attack with its tail. It's a melee weapon attack, +7 to hit, like all these things, makes all sorts of damages and all of that. So first statement is like whenever somebody gives you documentation or like a spec, when they tell you it's true, what they really mean, it's usually true. So expect lies everywhere. Like for instance, there is a flat out lie. It's like I read before from the rules, like a melee attack is always supposed to be 5 feet. Guess what? It's like the stinger attack is a melee attack, but the reach is 10 feet. So 5 feet is not true, even though it's in the rules. It's mostly true, but it's going to be sometimes wrong. So never trust what people tell you about specs and documentation. Step 1. The other thing is like modeling-wise is like when I looked at the goblin, it looked like it was doing 1 type of damage. Guess what? Is like the Wyvern is doing 2 types of damage. I have like piercing damage, so that's like the thing piercing you, and you also have potentially poison damage. So how would I go about modifying my model to do that? It's not very complicated. It's like all I need to do is like instead of having damage being like one or the other, I just need to make it into a list. And the list is going to be something like a list of damages. So I can say a damage is going to have a dice roll that does it make like a 1d20, 1d6, whatever. And it's going to have a certain type. And now all I need to do is I need to say the attack is going to have this damage and this damage and this damage. If you were nitpicky, you would say also this is nice, but like now you're creating another of these impossible cases, because now I could create an attack with an empty list of damage, which is a bit of a problem. So really technically what you should do is create a list which is never empty. That's fine. So we're going to pass on that detail. Another thing we see on the Wyvern here is we have something which is not at all in the Goblin. And so the target must make a DC 15 Constitution saving throw. So what this is saying is that when it's attacking you, you need to throw a dice. And if you're unlucky, you're going to get poisoned. If you're lucky, everything is fine. So we don't have a way to model this in our attacks for now. So how would you do that? The way I would look at it would be to say like most attacks are simple. They do one type of damage. Some of them have optional stuff. Most of the times it won't be there. Sometimes it will be there. The way you would model this is by using what's called an option type. You can loosely think of it as something similar to a nullable type. So this would be saying like typically an attack will not have special stuff. Sometimes it will have optionally special stuff. So I'm not going to detail the special stuff, but this is how I would handle this. Another thing I hit modeling attacks was the following problem. If you look at weapons and attacks, you will find that a weapon can be a heavy weapon or a light weapon. So heavy is like something big, like where you do a lot of damage, and light is like something light, not going to elaborate on that. And so looking at this is like you would say, obviously this is a discriminated union, because like if it can be heavy or light, it's like fine, like we can do that. So we would do exactly that, create a weight, light or heavy, and the weapon would have a weight property. This is fine, except that this is not right. The problem we have here is that if you take a weapon can be heavy, it can be light, or it can be none of these things. So that's an issue, because a discriminated union should be mutually exclusive and collectively exhaustive, or in other words, is like the thing should always be in one of the possible cases. So now it's like I have no way to represent the case which is not heavy or light. So how would you do that? One is like light or heavy is not right, because I cannot represent none of these. So there are two approaches you could do, and both of them are kind of valid in a different way. Like the first one is saying, fine, what I told you is like the weapon can have like none of these things, or it can have a property which is either heavy or light. So I could do something like an option and saying it's either none or some, and if it's some, I will tell you if it's light or heavy. That's one way. It's probably the best one domain modeling wise, because it's the closest to the truth. Like it's really saying you can have this property or not. Another way you could do that is by saying like I really need a third case, so I'm going to give it a name, like maybe medium, like a weapon can be light, heavy, or medium. The benefit here is going to be easier to work with, because I don't have like nested types. I don't need to look inside the type. The drawback is like I kind of like the idea of ubiquitous language. Like I like my code to look the same way the language looks, and medium is nowhere in the rules. It doesn't quite exist. So this one is like easier to use, but it's like less correct representation of what the rules say. So pick your poison. Do you want to be correct and take some pains, or do you want to be less correct but make your life easier? Last one, briefly, one thing about discriminated unions is that discriminated unions are closed. What this means is that they are not extensible, and so whenever you use a discriminated union, you should think about like, is it possible at all that somebody will want to add something to this list? For instance, it's like if you had a list of weapons in the user manual, and then you should probably not use a discriminated union here, because people could be creating all sorts of fancy weapons which are not defined in that list. So in that case, if you want extensibility, you don't want a DU. You probably want a list or a collection or something else. So yeah, questions to ask, like one or at least one that was like for the damage, one or maybe one that was for the weirder one. Is it really closed, and are you covering all the cases in your discriminated union? So one thing I like here is I literally spent like weeks asking myself the following question: is this a record or is this a discriminated union? And modeling and modeling and modeling. Back in the days when I was more into the OO world, I remember this advice, like you should always use composition over inheritance. This is the way to go. If you look at what I've been doing here, this is exactly what I've been doing. Zero inheritance, and everything is like composing blocks, like records with DUs with records with DUs. So that type system is embracing this approach completely. And what I like is like it's refreshingly simple. It's literally you're asking, is it an AND statement or statement, and you just keep going until you have nothing to do. So very nice for domain modeling. Now I want to move to another question, which is the question of dice rolls. So why do I want to talk about dice rolls? I want to talk about dice rolls because dice rolls are everywhere in Dungeons and Dragons. And so you, for instance, you see something here like damage is 1d6 plus 2. So it has its own language. It permeates the whole game. So it has a syntax like you have d4, d6, d8, d10, like how many sides you have, and like you can compose them into expressions which define like what type of how do you use the dice. So what we would want is like we would want to be able to model that in our language. Because that's what we need, right? So it's like how would I go about modeling this? So to do this is like I remember like in my own adventures, like I ended up meeting a legendary character called Thomas Petricek, a half-elf wizard from Prague. And if you watch these talks, is like a lot of them like use the same technique, which is like model expressions using discriminated union. So I thought maybe what I'm after is this, and I want to use expressions for my dice rolls. So what we want is like we want to be able to say something like a damage is like 4d10 plus 2d6 plus 4. And so this, I could have like many roles, I could have one role. So I want this to be as complex as I want or as simple as I want. If I look at this, it's like this is really an expression. I have 4 things in it. I have roles, like 4d10, which is saying really take a 10-sided dice, roll it 4 times. I have integer values, I have a 4. And I have a combination, which is by using addition. So these are the 3 things I need to support. So let's try that out. And now I'm going to go quickly into VS Code to give you a sense of maybe how you could approach this. So what I want is I want to model something like 6d10 plus 4. Is this big enough in the back or should I bump it a bit? A bit, okay. Better? Cool. So we need a couple of things. Like the first thing we will need is we will need dice. That's not too hard. Like you're going to use a classic trick. And the trick is to use what's called a single case discriminated union. So I'm going to say a dice is something which contains, which has like a number of sides. And so if I do this, now I can do something like a d6. This is a constructor. And if I do d6, it's going to give me a dice, which is a d6. I could do d10, I could do d8, I could do all these things. Cool. So dice, that problem is solved. Next problem is like I want to represent roles. So this is a bit trickier. To represent roles is, let's do a type. So what I really said is like a dice roll can be one of 3 things. The first thing I can have is I can have a roll. And a roll is going to contain a bunch of things. It's going to contain like how many dice, how many times I want to roll this, and like what dice am I talking about. So that's not too hard. So that's one part of the expression. The second thing I need is I need integers. So I'm going to call that a value, which is going to contain a number. And the third thing I need is I need to compose them with an operation. So I'm going to call it simply add. And what do I add is I'm going to add a list. And that list should be a list of dice roll because I can add whatever I want. And this is neat because like with this is like I have completely my expression model in like 4 lines. For instance, what I can do here is I can do something like this. I can do like let a roll equals, let's say, a roll of 4d6. So that's fine. And I can like I can add this. So I can say add roll of 4d6, and I can add this to a value of 10. And I can add this to another roll, which should be a roll of maybe 2d10. And if I run this, it's like I'm going to see that this is indeed giving me a dice roll. So like really straightforward. Like if you want a roll with just one number, that's done. If you want like 27 different dice, that's done as well. I can go as complex as I want. My whole expression is done. Now, if you look at this, it's like this is nice, but this is not that nice. What I wanted was something which looked like this: 6d10 plus 4 plus 2d6. What I got is like something which is technically what I want, but which looks ugly as hell. So I got the right expression. Can I make it prettier? The answer is yes, I can. So I can, by doing a couple of things. The first thing I could do is I could say, let's create d4 equals d4. Just create a couple of instances. Let d6 equal d6. And I can create all my dice. So not too complicated. But that's not addressing much of a problem. So I'm going to take my roll here, and I'm going to just move it here. And if I do that, so now what I can do is instead of d6, I can say 4d6. And here I'm going to do 4d4 because I haven't created the other one, but you get the idea. And so this is still a roll. This is still a roll. The compiler is happy. So good. But really, the main problem I have here is like something like value of 10 is absolutely ugly. What I would want to be able to do is like say like add 46 plus 10 directly. How would I do that? Not too hard. It's like all I need to do is like, so this is where you use a bit of trickery. I didn't know this was possible until actually recently. And so what I can do is I can actually add member functions on a discriminated union. So I'm going to use that, and I'm going to do something like create an overload static, let's say static member. And I'm going to do plus. And so this is going to take, is this what I want? Yeah, this is, and what I'm going to do here is I'm going to do something like, I'm going to give you, so if I'm going to add things together, what I want is like, I want the first thing is going to be maybe a roll. And the second one is going to be a value, so it's going to be x, and that's an int. And here the trick is going to be to do something like this. Is like I can take that thing and I can actually wrap it into a value and give you back what I want. So it's like if you give me plus of a roll and an int, what I'm going to do is I'm going to give you back add of the roll and of a value of x. And so let's run this and see what happens. So if I do that, what I should be able to do now is the following, is I should be able to do something like roll for d6 plus 2. And if I run this, is like, guess what? Is like I'm getting a dice roll. So it's like now this is looking much nicer. And I can directly add a number. So I could very easily do the same to a 2 plus roll for d6. So what this would take would be to add another overload to this. And I could use the same trickery also. The last trick I would want to use, but I'm not going to implement it, would be roll for d6 is kind of ugly. So the trick I would use is like I would actually do something like 4 times d6, add this as an overload on the dice, and if I do this, I'm going to end up with something which looks like this. So what I will have is something which looks like this. My whole model will be like my dice is going to be the same as before. I have the multiply thing, which is going to help me do something like 4d6. Dice rolls are the same way as before. I have a bunch of overloads. And so at that point, is like what I can do is I can do something like 1 plus 4d10. That should actually work. I don't know why. Okay, 1 plus 4d10 plus 2 plus 2. So now is like I'm like not 100% to the same representation of what I had, but like extremely close to what I wanted to represent. So this is what I did. So hope this is useful. Like I think it's pretty neat how like with discriminated union you can represent very easily your own internal domain language. And like represent like expressions like that, like create a language inside the language, like in this case, the language of dice. So let me go back to my slides for a sec. So what I did was I created a DSL, which was remodeling expressions. Like this is exactly the representation of what I had. Is like either I have like a dice representation, I have roles representation where I'm representing like essentially both the entities and the operations I support, and I can then represent exactly what I want. And then the next step is once you have the DSL, first you want to get it right. My advice is like do it so that first you want to be correct. Don't forget, don't focus on being pretty. And then is like try to make things prettier and prettier and prettier. I'm using like that type of trick everywhere, including for business applications. Like I've done things like implementing a small version of Excel inside another thing so that my customer could write whatever functions they wanted. I've been using it for completely different things like modeling blog posts, so that I could actually take this and like interpret it into different formats. So it pops up everywhere. Like once you start to see what you can do with expressions and how easy it is like the sky is the limit. So it's like first like do it right and then make it nicer by using a bit of trickery. Usually the trickery involves like building something like constructors. If you think like about what I have been doing with transforming value of 6 into 6, all I did was creating something like a constructor function or a helper function to construct that more easily. So very powerful trick and very useful. Good, so now I want to move to the last part of our adventure, and that would be Fable-Elmesh. So let's talk about Fable-Elmesh for a second. So initially my goal was to model the rules. I really had another goal in mind, and the problem I had was the following. Like the first time I played with my friends, we played like for half an hour, and then they encountered some goblins, and I nearly killed everybody. And so this was not great, right? Like they were playing for the first time, and in half an hour you die. Like this is no fun. So I thought like this is a problem. How do I know that the fight is fair? And can I actually get a sense for that? Like this is so since then is like one of my focuses has been the following question: can I know beforehand if the fight is fair for my players? And what I mean by that is like if they don't do anything silly, like if they do something silly, it's fine, they should die. Like that's okay. If the monsters behave normally, I would want a probability of survival which is reasonable. So how would I approach this? So what I want is I really want to build a simulation. So something like here is the situation, run it 1,000,000 times and tell me like how probable is it that everybody dies. And so to do that, I need two pieces. One is like I need all the rules, because if I don't have the rules, I cannot simulate the rules. So I need to implement the rules. And two is like I need a way to make not silly decisions, which means like I need the goblins to make decisions. I need every creature to make decisions. So I need all these components into my model. So let's look a bit at what's happening inside a combat turn, like where I ended up with this. So on a turn, during combat, you can move, or you can take one action, like attacking or doing this type of things. So in practice, what this means is like during a round of combat, what you have is like an option, a bunch of options you can do. You could move north 5 feet, move west, still move north because you still have movement left, and then you could make an attack because you still have like an action, and then at some point you're done because you cannot do anything else. So the modeling here is like, again, guess what? Discriminated unions. So I'm modeling the actions. It can either be a move with a certain direction, it can be an attack on somebody with a weapon, or you're done because you don't have anything else to do. So this is what you can do on your turn. And so to do that, I also need some form of a state. Like if you move north, I kind of need to know where you are. If you attack a creature, I kind of need to know if it's alive, all these things. So I need a state which is going to have probably all the creatures in some form of a state. Which creature is actually allowed to do things now, and like in what order are they allowed to attack. And so what this means is like one way to represent combat or the game is a long succession of updates where like you have a state. Every time you're going to get a message, like which creature is doing something, what is it that they're doing, take that action, apply it, update the state, and keep going and going and going. So it's like state, update with an action, and keep going. Which really ends up looking like this, right? It's like a game is going to be a long sequence of commands, like creature 1 moves north, moves west, attacks, and then another one, and so on and so forth. And to know what my state is right now, I need to know what was the initial state, what are the commands, and I fold that to know where I am now. If you've been doing anything like event sourcing, like this should be looking awfully familiar. Like that style, or like functional style, or like that type of modeling and functional languages lend themselves very nicely to that type of approach. So this is what I have been modeling for combat. I know like what I wanted was this is nice. I can run this in my editor and see what happens. But sometimes it's much nicer to be able to see it visually. So I thought like maybe what I need is like an application where I can see what happens. So this is where I looked into this project called Fable Elmish. So Fable Elmish is two things. It's Fable and it's Elmish, like a big surprise. Fable is an awesome project. What it is that you can take a piece of F# code, and Fable is a transpiler. It's going to take that code and transpile it to JavaScript. So you get like JavaScript out of the box. This is great because I suck at JavaScript, so that problem is solved for me. Elmish is a pattern which is coming from the language Elm. It's using a pattern which is known as a model view update. So Fable Elmish is an implementation essentially of ideas like Elm in F# using the transpiler to JavaScript. And one thing which was nice, so let me show you first like how the pattern looks. Like the model view update pattern looks along these lines. You model your application in terms of messages, like this is what you can do, like what the actions the user can do to your app. You have a model which represents the state, and you have an update function. And so anytime a message comes in, it's going to trigger the update function. The update function is going to update the model, and is going to wait for the next message. And when a message comes, it updates, and it keeps going and going and going. So that's the core. The other part is like if you want an application, you probably want to see something. So anytime the model is updated, it will update the view, like automatically. Like in the case of Elmish, it's using React. So it's like anytime there's a change pop, like it just happens. And you also need to start where you come from. So that's the init function. So an MVU application has really like 1, 2, 3, 4, 5 things. That's all you need. If you have this, like you're done. And this is a perfect fit for what I have. My messages are the commands or the actions I showed you. I can plug that right in. My model is the state I showed you. All I needed was to plug it in Elmish. And this literally took me 15 minutes. My mind was blown away. I took my code, shoved it into it, compiled it to JavaScript, and I had a page which was running and showing me a combat happening. So let me actually show you that I told you I had this. So let me actually show you my pride and joy. the ugliest web application ever, but my current implementation in Elmish. So here I have like code, which is it's all F#. Like I have brain, I have data, this is my domain. It's about like 2,000 lines of code so far. So this is F#, and what I'm going to do is I'm going to do npm start. And if I do npm start, it's going to do lots of things. It's starting Webpack. It's taking my F# code and transpiling to JavaScript. It's going to spin it up, and we should be able in a couple of seconds to see what this application is doing. I love this too because like within 15 minutes, I went from like I don't know JavaScript to I'm a full stack developer using all these things. This is awesome. So now it's compiled. And what I should be able to do is I should be able to go back here where it's telling me like this thing is now running locally at localhost. So I'm not expecting this to come anytime soon or Steam or be a hit, but like what you see here is a combat simulation where I have like 3 wolves and 3 goblins. And what you see here is like currently this goblin is up and can do all these things. It can move north. So for instance, it's move north. And when I do that, I can see the log of the action. So it completed the move. I can move north again, and I can shoot one of the wolves. And I can see that the attack failed. And now I'm going to finish the turn. And this other one can move southeast. So like what I'm showing you here is like the one, it's ugly, I'm aware of it. And the 2, it's probably the most boring way to play Dungeons and Dragons. Like but like the piece which is interesting too is what I did is this thing here. I can also switch to automated. And so instead of doing it by hand, is like now I can, I have a very basic strategy for the creatures. And so I can just let them play out and see what happens. As you can see, like right now, like the wolves are completely reaming the goblins. So that's not good for the goblins, and I can do it again, and I can do it again, and again, and again. And so at that point, I'm in a place where I can simulate the combat. I can do it like a million times if I want to. And so I should be in a good place to start to actually do what I wanted, which is like finding an optimal strategy for these things. Yeah, and I can, again, like the goblins are not doing very good against the wolves. I'm going to give them another chance just in case. Yeah, not good, huh? So I always want to see what happens. Like, sorry, like the one wolf is dead. Will he win? Okay, again. So like this, it looks like this is not very good for the goblins here. So this is the state of my simulator right now. Like this is what I built, and like literally like getting from like code running pure F# code, like modeling the domain to actually have a UI working took 15 minutes. Afterwards, there was a bit more work to make it pretty, but like it was working. So a couple of things I wanted to talk about before closing on this. So what I want is like what I showed you is like the creatures currently make automatic decisions. So one problem is like one problem I need is like what should the creature do? That's how we determine the strategy. But one first problem is like what can a creature actually do each of the turns? So the reason this was important was I don't want to have to deal with error handling or all of these things. Like there is many actions you could do. And like what I don't want is that I don't want to let you move north. If you cannot move north, then check, it doesn't work, redo it again and all of this. So this, I wanted to avoid all of this. And I was not sure how to model this. And then is like, I remembered again, like another legendary creature I crossed during my journeys, like Scott Vlashin, a legendary gnome druid. And Scott, in a talk a long time ago on a tic-tac-toe enterprise, brought up this idea of capability-based modeling. And so the has nothing to do with Dungeons and Dragons. It was more for security, but the idea was if you want to have a secure application, instead of giving people a lot of choices and validate if what they did is right, just give them the ability to do what they're actually allowed to do. So this is what I thought this would actually be pretty useful for me. And so what I did was instead of letting a creature do everything they could possibly do, including invalid moves, every time I'm pre-generating the actions you can do. Like I'm giving you only things which are valid moves. So this is great because now, because it's pre-generated, I show on screen only things you can do, nothing else. So it simplifies the choices. Also makes validation trivial. It's like I know that if you give me one of these choices I gave you, like this is valid, and I will just go ahead with it and run with it. So this is how I ended up modeling this thing. And I think that's, I think I'm going to probably skip in that part. Yeah, so like the model here is essentially like modeling every turn. The model is generating like whose turn is it, what other things they can do, and what information they have available. Like what monsters can they see, because you cannot attack somebody you cannot see, and so on and so forth. And so I'm modeling this with a decision. Like I have a thing which is called the decision needed. Like each turn, I need a decision from this creature, can do all these things with that information. Validation is easy. And the only thing I needed to do was to add, to make that run automatically on the MVU thing is like I needed to add a small component. So I added an agent or like a mailbox processor in the F# side. And so what this is doing is like it's saying like whenever a message is coming in, I'm going to trigger the update function. The update function is going to do its business as usual and update the model in the view. But the other thing I'm going to do is like whenever an update is happening, I know that somebody else needs to decide. And so what I'm doing is like I'm firing off a decision needed. Like at that point, the goblin needs to do an attack or move, and I'm sending it to the agent. So the agent is looking at this. I can plug in different strategies. So I can say like use an aggressive strategy, blah, blah, blah. The decision agent here is going to say, fine, like I need to make a decision. This is the information I have. Decide. That fires a message. The message goes back to the update. And now everything is cycling automatically forever until like all the wolves or the goblins are dead. So this is how I built this thing. Conclusion. First is like it's not complete. Like I was very naive. I really thought it would be like 1 or 2 months. I've been working on this for like over 6 months now, like nowhere close. So I still need to implement all the rules. It's one of these things where every time I solve a problem, is like 3 new problems pop up. So like it's not always awesome. So the things I need is I need all the rules. Specifically, I need to handle like buffs and debuffs. That's actually pretty difficult to do. Like things like now you have +5 on your attacks for 3 turns, or you have like a magical protection. I need to implement magic. So magic is easy. I mean, it's not easy in general, but like it should be easy to model. I'm not worried. And I need also to handle like terrain. Like right now it's just a grid, but you would want to have something like visibility, you can hide and all these things. So I haven't done that yet, but the one which is really hard for now is like all the effects. This one I'm struggling with. If you've done anything like game modeling and like have ideas on this, I'm all ears. The other one is like currently my strategies are pretty dumb. It's like I wrote like by hand how a creature should behave. Like if you see somebody and you can make an attack from far, stay away and shoot, stuff like that. This is fine. I'm a machine learning person, so what I want is like I really want to I build this so that I can actually learn mechanically what is the best behavior for a goblin if they want to win. So what I want to do, and I have now the tools to do that. I just didn't have time yet to implement the algorithm. The idea I want to use is something called reinforcement learning. So the idea of reinforcement learning is like let the game play itself like 1,000,000 times. And whenever you play, like try a bunch of different things. So try things and see what works and what doesn't work. And if you see that something works, try to do more of it. And if you see that something doesn't work, try to do less of it. And the theory goes is like if you do that for long enough, is like at some point the creature will do exactly what they should and will not do anything dumb. So that's the theory. I still need to see how it works. But this is where I'm headed. And what I would love is like to get out of this, like this is the strategy a goblin should follow or a spider. And they should normally tell me also like how long it's going to take, what's the probability of winning or losing for my players. The last thing which this project got me thinking about was this was surprisingly hard. So I mentioned that this took me a couple of months already instead of a couple of weeks. And one thing which has been puzzling to me is like typically when you have a software project, you don't get a full spec. Like it's rare. Maybe you do, but like I have never seen that. And so usually that's a good reason why you can't implement it, because if you don't have a spec, you don't know what to do. Here, I don't have that excuse at all. Like the rules are extremely clear. If I give you the book, in 2 hours you should be able to play a game and everything is fine. So the question I was asking myself is how come with a perfectly clear spec, how is it that I'm still working on this, and why is it that makes it so hard? So my thinking at that point is that probably a spec is not the same as a documentation. Like the rules are actually good documentation, but like a bad spec. As in like specs is about how you should implement it. Documentation is like giving you a view on how you should use the system. And these are actually quite different. So one of them gives you a mental model, will make all sorts of simplification, helps you see like overall this is how this works, but like going from that to the implementation is actually not trivial. In particular, like documentation tends to omit all sorts of obvious context information, which is important for implementation. If I told you like I never met you, but I want to meet you somewhere and I'm going to describe myself, I'm not going to say I'm a person with 2 feet, 2 arms, 2 legs, 1 head, and these things, right? But these are things I would need if I wanted to implement a human. So the way you would describe things to be usable by a human is quite different from implementation. So still, this one has still been puzzling me, and I'm still trying to figure out what is it that makes both of them different. Anyway, so this is what I had. So first, I want to thank you. And because we're going to keep the D&D theme and like in D&D tradition, I'm going to cast Bless on all of you. So like all your saving throws will be done at +4. And you can find me on Twitter. You can find my blog at brandewinder.com. The whole code I showed is actually on Monster Vault, like on GitHub. So if you want to look at it, you have ideas or you want to interact with it, like do so. And so thank you for your attention. Hope you got something out of it and that you have a fantastic rest of the conference. Thank you. Okay, it looks like there will be no questions. Yep. How does the decision agent work? So let me go back to the slide for a second. Like so the model I'm using is something like this. It's like first, I know that somebody needs to make a decision. So what I modeled was like every time I'm providing the agent like all the information it needs to make the decision or everything it's allowed to use. So I need to know who's making the decision. I'm going to provide you which are the actions you could possibly take. So at that point, what it is like the question is really like here are 5 possible actions. Pick the best one. And to do that is like I'm also providing like what I call information, like where are you on the map, what other creatures do you have. And so now is like I can write different functions which are going to take that information and do either good or bad decisions. So currently it's all handwritten, and I'm doing something like if I see other creatures and I have an attack, and maybe it's a long-range attack, I'm going to attack from far. If I don't have a long-range attack, move. So currently it's like very hard-coded on like what I would do as a player, and the goal will be to. This is where like this representation is useful for reinforcement learning, because now the whole thing will be like given a list of actions, play over and over again, essentially try the whole list multiple times and see which ones lead to good results. And that should help surface like which ones are the good ones and which ones are the bad ones. And that would be a strategy. So currently handwritten, the goal is to make that mechanical. Does this answer your question? It doesn't, but like this is the creature doesn't. Like when you do the decision, you see exactly what you would see normally. What the algorithm would do afterwards is like keep track essentially of the decisions which have been made and look at it like 1 step forward, 2 steps forward, or maybe until the entire combat, and look at when did you die, when did you win, and like try to pick the path which actually goes to living. Uh-huh. Yep. So the question is like the comment is like why not use something like Minimax? I could do that. I could do Minimax as well, but like the Minimax, what I would really like is like I would like to see something which tells me explicitly in this situation this is the action you should take. Or I think they're complementary. Like the Minimax would be a way to maybe measure a good decision, but like reinforcement learning is interesting because it's going to look at the entire game normally. Like look at like, just 1 step is okay, but what I really want is like I want to know in the end I want to live, right? So it's like other questions? Yes. To do the type of thing, so the question is how to start on a DSL like this one, for instance. I would say like I think it was last year or the year before at NDC Oslo, Thomas Petracek like gave a really good talk on modeling Excel online with F# or something like that. Like, and he's showing a very, very good example of this. Like that should show you good patterns, and the patterns are not very complicated. Once you have done it once, it's like you will see it. Like it's kind of always the same. So I would recommend looking at that talk. Correct. Another recommendation would be take a look at the Scott Vlashin's book on domain modeling made functional. But I think he's talking less about expressions, like specifically on the DSL for expressions. Like Thomas's talk would be very good. On general domain modeling with F#, I would say Scott's book is very good. One last question, perhaps? No questions. Then have a great rest. Yep. The goblins. Yep. Poor goblins. They always die. The goblins always die, and like part of it is probably because the strategy. So first, like that's kind of what happens in movies, right? Like orcs, goblins, like they are there like by the million, and they just all die. Like this is really sad. But I think the reason they die is like first, like probably the combat is not balanced. That's when that would be the conclusion I would draw. Like if I play it like 100 times and like the goblins die 95% of the time, is like it's probably that the wolves are stronger. The other side is also like currently the strategy I'm using is like handwritten, and the strategy I'm using is probably not very smart. So it's like this is why I want to use reinforcement learning, because I could spend a lot of time trying to find out by hand the strategy which works. I want to do it mechanically. So probably they are not very smart at the moment, which is kind of correct because the goblins are not very smart anyways. Yes, but like that would be an argument for why I would expect them actually to win more often, because like having arrows is an advantage, right? They should be able to stay out of range from the wolves and just like snipe them, and they don't for the moment. Or the wolves essentially rush at them and like completely crush them. So this is what's happening. Yep.
Would it be hard to adjust the difficulty down if your machine algorithm becomes too good and all the players die?
So I wish I had that problem. So it's like what you're saying is like maybe at some point you will have built Skynet for goblins, and the goblins will be so amazingly smart. And so I will think about that problem when I have it, but like that should be possible. Like I should be able. First, I need a good strategy, and then I will see if I can tune it down. Yep.
So defining a good strategy. I mean, a goblin acting as a goblin should be the good strategy, right?
Yep.
So maybe not all the time winning. So would you consider implementing different personalities as the target for reinforced learning?
Yep. So the question is like, should you really have like one strategy in general, or like should a goblin behave differently from say a wolf, or like
a brave goblin versus a cowardly goblin?
I like it. Like we want goblin heroes. No, it's a great question. I have been thinking about this. Like, so this is a kind of technical, but or like first I want to start with something which should work in general. But like I've been thinking about things, for instance, like alignment. Like you have this idea of alignment where like creatures, some of them are evil, some of them are good, some of them are neutral. And like if you think about it, like that should result in different things in combat. Like if I'm evil, I'm going to do bad things. I don't care if my friends die. If I'm good, is like I will probably go to battle to save everyone, even though I might die into it. And so I think also I think I can find a general strategy which should work, because like the creatures have different abilities, and just that should give you different strategies, or they should use their abilities differently because they have different abilities. But it's possible. I might end up like doing different things for different types of creatures. I don't know if I'm going to learn a strategy for goblins or a strategy for monsters, which then applied to goblin will result to a good strategy for goblin. I don't know if that answers your question. So I don't have a 100% sure answer on this. Is my answer.
Right. So I was thinking like some goblins might attack when they're on high hit points, but they run away if they're.
Yep. That would be what you expect from a neutral or maybe evil person. Like if it's going bad, it's like I don't care about my friends, move away. Like let them die. Like I want to live. So I think it's like time. So thank you again. Like have a good rest of the conference. And if you want to talk more about this, I'll be around. I could talk about like D&D for a long time. So like as much as you want to talk, I'll be there. Thank you.